What you saw was a theory. Now we want to prove the theory, that is, reduction of sea ice and storms are two causes of making storm ridges. Also, the reduction of sea ice increases the thickness of active layer. Our information and data to prove these theories are field data that was collected by Jonas Åkerman during past 3 decades, sea ice data that is being provided by National Snow and Ice Data Center of the United States, wind data from Norwegian Climatology Institute, local air temperature data, and also global air temperature that is provided by National Data Center. Numeric analysis proved the reduction of Arctic sea ice area increases the storm ridge occurrence. When the sea ice area reduces to 9.7 million square kilometers or less, the ridge will be formed certainly. National Snow and Ice Data Center also provides the monthly shapefiles of Arctic sea ice extent. The distance of Arctic sea ice border from the catchment was measured through these shapefiles. At least 100 km free ocean distance is necessary for waves to be formed and be strong enough to create the ridges. We call it effective sea ice distance. After measuring the mean monthly sea ice distance from the catchment and regression analysis, it was concluded that there is a direct relation between the number of months with effective sea ice distance from December to March and the storm ridge occurrence. The more months with effective sea ice distance results in more storm ridge occurrence. It means that ridges are formed within a few months. The data shows there is an increase of effective sea ice distance during the past decades. It means storm ridge occurrence will be a normal phenomenon within a few years. There is correlation between the number of days with wind speed more than 7 meters per second within the west sector during autumn and winter and storm ridge occurrence. The more days with high wind speed results in more storm ridge occurrence. Until now, we proved that the less sea ice area and also the more days with wind speed more than 7 meters per second results in more storm ridge occurrence. Another factor that was studied in this research was active layer. The active layer is a top layer of permafrost that thaws during the summer, then freezes during winter. Permafrost contains methane, that is one of the greenhouse gases that causes global warming. The warmer the weather, the thicker the active layer. The Arctic sea ice changes influences on active layer thickness through a chain relation process, as you will see. Now we want to prove it. We want to prove that there is a relation between Arctic sea ice reduction and active layer thickness increases. There is an inverse correlation between Arctic sea ice area and global air temperature. The less Arctic sea ice result in higher air temperature. It is obvious that Spitsbergen is a part of the global system. The higher global air temperature, the more local degree day thaw. The analysis in local scale proved that the less sea ice around the Svalbard results in more local air temperature. Degree day thaw is the accumulated daily mean air temperature above zero that results into thawing the active layer. Analysis also showed there is a direct relation between degree day thaw and the air temperature. The higher the air temperature, the more the degree day thaw. And also, the more the degree day thaw, the thicker the active layer. The final result is the reduction of sea ice increases the thickness of active layer.